Imagine a 30,000-pound machine tearing through the sky faster than the speed of sound, yet entirely invisible to the sensors actively trying to hunt it down. Hi, welcome to the MKN universe. Let's explore the F-35 Lightning II. The core defense mechanism of this aircraft relies on managing its radar cross-section, or RCS. This is the measure of how detectable an object is to incoming radar waves. To survive in hostile airspace, the jet must deflect those waves instead of bouncing them back to the enemy receiver. This diagram breaks down the radar range equation. Because detection range is proportional to the fourth root of the object's RCS, shrinking the enemy's detection distance by a factor of 10 requires shrinking the jet's radar signature by an immense factor of 10,000. This schematic reveals how the F-35 forces that reduction. Notice the geometry. The wings and tail utilize matching sweep angles to scatter radio energy. Overlaid onto that is an advanced skin of radar-absorbent materials, woven into the exterior using heat-resistant composites. By combining sharp geometric deflection with advanced absorption, this massive fighter jet registers on an enemy radar screen as an object the size of a golf ball. It fights inside a mathematical blind spot. Look at this massive piece of hardware. This is the Pratt & Whitney F-135, the most powerful engine ever installed in a Western combat aircraft. With the afterburner engaged, it generates 43,000 pounds of thrust. This equation demonstrates why that raw output matters. By dividing the available thrust by the total weight of the aircraft, we find the thrust-to-weight ratio. When fully loaded, the F-35 achieves a ratio greater than 1, giving it the kinetic energy to accelerate straight up against gravity. But the F-35B variant takes that raw lineal thrust and manipulates it for short takeoff and vertical landing operations. This diagram illustrates a mechanical solution, the Rolls-Royce lift fan. A specialized clutch connects the main engine to a downward-facing fan positioned right behind the cockpit. When engaged, it forces a massive column of air directly downward. That directed air column produces 20,000 pounds of vertical lift. It gives the jet the capability to launch from short, austere runways and land on the decks of amphibious assault ships anywhere on the globe. In older dogfighters, pilots had to manually piece together data from individual radar and threat screens. The F-35 bypasses that entirely through sensor fusion. The onboard computers ingest every radar bounce, infrared signature, and radio emission, merging them into one clean, cohesive battlefield map. The system feeding that map is the distributed aperture system, shown here. 6 high-resolution infrared cameras are embedded flush into the hull, recording a seamless 360-degree spherical view of the environment. You won't find a physical heads-up display on the dashboard of this aircraft. All of that fused flight data, targeting information, and night vision imagery is projected directly onto the visor of this custom-fitted helmet-mounted display system. By tracking head movements and pulling camera feeds, looking down allows the pilot to literally see through the metal airplane to the terrain below. The F-35 secures its dominance through data supremacy. The pilot visually identifies and locks onto hostile targets far before the enemy is even aware a jet is in the sky. This image highlights an AIM-120 AMRAAM missile, the primary air-to-air weapon utilized during what strategists call the first day of war. In this phase, the F-35 operates in stealth mode, keeping all ordnance tightly packed inside internal weapons bays to preserve its invisible radar profile. Later in a conflict, once enemy air defenses are systematically destroyed, stealth becomes unnecessary. The jet enters beast mode, mounting external pylons onto its wings to carry a staggering 18,000 pounds of cruise missiles and laser-guided bombs. The aircraft physically adapts to the tactical environment, operating as a silent, precision assassin on day 1 and a heavy ordnance bomb truck by day 3. This photograph captures the mile-long final assembly and checkout facility in Fort Worth, Texas. It is the hub of an incredibly complex global supply chain, supported by additional international manufacturing lines producing jets to meet worldwide demand. That demand spans multiple allied nations. Pictured here is the F-35I Adir, a highly specialized variant built for Israel, featuring deep country-specific modifications to the internal electronic warfare systems and data links. These figures represent the staggering economic weight of the program. Purchasing a single jet costs between $82 and $109 million. Over the program's intended lifespan into the 2080s, the total maintenance and operation costs will approach $2 trillion. That cost is driven by continuous evolution. The military is currently executing the technology refresh-free and engine core upgrades, swapping out the jet's core processors and thermal management systems to handle the extreme power demands of upcoming electronic warfare capabilities. The F-35 operates as a modular, ever-updating digital node, capable of rewriting tactical combat strategy for the next 50 years. For the PDF, check the description. Subscribe to the channel for quick and more updates.